Hey guys, so in this video we're going to be talking about 7 through 12 from 13.5 to 13.6. And in this section of the homework, we're going to be talking about what happens when you want to try to use the law of sines, but you can't. Okay, and there are two types of problems. One where we have all three sides but no angles, and one where we have two sides and the angle in between them. Those are the two cases that we're going to look at here. So last time when we talked, we said that when we had a triangle that's not a right triangle, that if we had both A and A or B and B or C and C, if we had an angle on the opposite side, we can use the law of sines. If we don't have that situation, that's when we're going to go to the law of cosines. Now, the law of cosines is one formula that actually gets written in three different ways on a pretty regular basis. Typically, the most whatever letter you're starting with, you won't see it again until the capital version. So with the law of cosines, it allows us to solve for something opposite from the angle. So I'm actually going to start with the more complicated version, which comes from the very first question in your homework. Uh, we have, okay? So if we have this triangle and we want to acknowledge we don't have any capital A is in I just need to pick an angle that I want to go after. And since the law of cosines gives me all the choices I want, I'm just going to go after A. It's as good as any. And so we're going to set up the law of cosines using the A information. Now, as a side note, little a would be the 17, little b would be the 13, little c would be the 11. We're going to go directly across the triangle. So I look at this first equation, so a squared, 17 squared equals squared plus c squared, 11 squared, plus 2 times 3, which is 14, times 2, which is 11, cosine of the unknown capital A. Remember, I started with little a, we're only going to do this once. It's a more challenging version of this problem. And with you guys being away from campus, I'm not going to focus on this a ton, but I do want to make sure you guys are aware of how these are solved. What really causes a lot of grief is recognition that there is a multiplication right there, which means that this part of the problem is different than this part of the problem. I can subtract 13 squared and I can subtract 11 squared. I cannot combine it with this 2 times 3 times 11. Those are separate things. And so what I'm going to do right now is I'm going to minus 13 squared and minus 11 squared. That's going to cancel out those two guys. And let's see where that takes me. If you use your calculator, you do 17 squared minus 13 squared minus 11 squared. You should get negative 1. I've got all that right. Okay. Calculate what this thing is right here. 2 times 13 times 11. Now keep in mind, this is negative. So it's negative 286 cosine of A. Alright? Alright, so now we're going to divide cosine of A will equal, divided by negative 286, not bad. 1 divided by 286, 0.0035. To get rid of a cosine, we have to apply a cosine inverse. Capital A would come out to 89.83. This is so close to a right angle, but it's not a right angle. So up here for angle A, I'm right 89.83. The rest of this problem, now that I have a complete A over A, I can use the law of sines. We're going to remember from our last assignment, if I'm looking for B, I would say that the sine of big B divided by little b, the sine of big A, 9.8, over little a. If you didn't do the first part of the assignment with law of sines, this is all going to feel brand new to you. So it's really important you take the time to complete the homework, the denominator, and get the sine of equals. And I'm just using my calculator off to the side. Feel free to use Desmos as a way to check these, or use your own calculator if you have one. We're going to sine of 89.8 divided by 17 and times by 13 produces 0.765. Again, to remove the sine function, we're going to take the sine inverse of that value. And if this doesn't make sense, come talk to me during office hours. But I'm going to get to 49.9 degrees. 49.9. Now, again, I made this number, these numbers up. This probably isn't the nicest angle, but I know that I have to get 180 degrees. So if I take my 89.8 and I add my 49.9, I get 139.7, and if I subtract that from 180, I'm going to get 40.3. There is my answer. You should only ever use the law of cosine one time. That's to produce a magnitude. After that, you can use the law of sines to finish every problem. Let's look at one more example, the one that you're going to get probably about 5 practice problems and a test question from. Ignore all of that. That's gone now. Give ourselves a basic right triangle. This is 50 degrees. And this is 12 and 17. Okay? We'll call this A, B. Notice because we have angle A, we're going to choose to use the version of the law of cosine that uses angle A. So again, I'm going to stick with that same information. Off to the side here, we'll say A is 50, B is unknown, C is unknown, little a is unknown, little b is 17, and little c is 12. Notice I don't have both A's, I don't have both B's, I don't have both C's. That's how I know the law of cosines is my only choice here. So my A, my little a is unknown, so A squared equals little b is 17 squared plus little c is 12 squared minus 2 times 17 times 12 cosine of capital A. The nice thing about this version of the law of cosine, this version of this type of problem, is that there are no unknowns on the right-hand side. So I can just type this into the calculator. I would encourage you to type the entire thing. In fact, I'm going to grab Desmos right now, and we are going to put in the whole thing. This would be 7. I've got a different problem here. 17 squared plus 13, no, plus 12 squared minus 2 times 17 times, oops, 12 times cosine, which is in my functions, of, we said 50. Now, it is important. Make sure you've checked to put yourself in degree mode. If you're not in degree mode, you're going to have a problem. So I end up with 170.7. But if we remember from looking over here, that isn't answer. So come back to Desmos, and we're going to take the square root of 170.74. We get 13.1. So that means if I come back to my problem, that little a when I have a choice, choose the smallest angle if I have a choice. So I'm going to choose A and look for C. I'm looking for capital C, sine of big C over 12, sine of big A, 50 over 13.1. Should have gotten that from the last part of the assignment. If we take 12 times the sine of 50, divided by 13.1, 0.7. We take the sine inverse. Capital C is 44.6. I want to put that here, 44.6. On my last one, I'm just going to add 180. 180 minus 50 minus 44.6. And only have 85. The reality is, it didn't really matter, but if there was a chance that B turned out to be obtuse, the law of sines would have broken down and not quite worked for me. It's hard to know that it's not working. And this is why it's important that we have sort of rules about using things like the law of sines. Always go for small angles. And if we were in the regular classroom, we would have a whole big discussion on why that is and what the programming of a calculator does and doesn't do for us. But for now, that should be enough to help you be successful on the test. Good luck.